will not take an hour. Okay, this unit, Unit 5, is all about graphing quadratics. If you look at the page before, you see an example of a quadratic, and it also has some vocab, like different terminology that I'm going to use that you'll be responsible to know. So like the vertex is either the max or the min. It's either like the peak or the valley, and that's where it changes directions. Then you have a y-intercept, which is where it crosses the y-axis. Your zeros, that's where the x-intercepts are. We'll talk more about solving something like that in the next chapter. But for now, this unit, so I decided this year to split up quadratics into 2 units because last year it was kind of stressful. It was just everything combined. So we're just graphing in this unit. And then in the following unit is when we'll get to like factoring, quadratic formula, that kind of stuff. So you have a little bit of time before you have to remember how to do that. So in this chapter, there are 3 different ways or 3 different forms of the quadratic form or quadratic equation that you'll be given. So there's standard form, there is vertex form, and there's intercept form. So 5.1 is all about how it's written in standard form. And you'll see it at the top, but I'll just rewrite it. Standard form is f of x equals ax squared plus bx plus c. So your exponents are in descending order, so it's x squared, x, and then your constant. And a, b, and c are all different integers or different numbers. And so when you're answering each question, there's kind of some steps that you're going to go through and that you're going to answer, and then you should be able to graph it without a calculator. So all of these equations you should be able to graph without a calculator, and most of this stuff would show up on a non-calculator portion, because if you have a calculator for it, then there's no point. So here we have an equation, y equals negative 2x squared minus 4x plus 5. My a is negative 2. My b is negative 4, and my c is 5. For part A, it says opens, and then you have to tell me whether it opens up or down. This is all based on the sign of your a value. So if your sign is negative, then you say that it opens down. Therefore, if it opens down, it looks like it's facing downward, so you have a maximum. So down and maximum always go together. Then if you had one that opens up, you would always have a minimum. That means it's the lowest point. So if it opens down, that means that is the highest value of your function. It does not go any higher than that. So that's your maximum. If it opens up, then you have a minimum. That means that's where it starts, and then it goes to positive infinity. For part B, it says find the axis of symmetry. That's what AOS stands for. Now, this is a formula that you do have to memorize. It is x equals negative b over 2a. And so an axis of symmetry is just like, imagine taking, so the picture that you see of the parabola to the left, imagine taking it and folding it in half. It is that vertical line that cuts it in half. So negative b, if I have negative 4 over 2 times negative 2, you end up getting 4 over negative 4, which reduces to negative 1. So my axis of symmetry is x equals negative 1, which would be this positive line, or this vertical line right here. You don't have to put a dash mark. It's just helpful for me. To find your vertex, you're going to take your axis of symmetry, your negative 1, and you're going to plug it back into the original formula. So a vertex is always an ordered pair. So I'm going to plug in, when x equals negative 1, what is my y value? So negative 2, negative 1 squared, minus 4 times negative 1 plus 5. And make sure that when you're doing this, that you put your value in parentheses, because like what will happen is whenever you take this negative 1 squared, it's going to end up becoming a positive 1. So the biggest mistake I see people make is that they don't put their x value in parentheses, and then it ends up causing them to get the answer wrong because they did not use the correct sign. So negative 1 squared is just 1, so you have negative 2 plus 4 plus 5. So negative 2 plus 9 is 7. So my vertex will always be in an ordered pair form. So the ordered pair would be negative 1, comma, 7. Normally, whenever you're graphing these, you are going to show me 3 different points. And so in this next case, if I find the y-intercept, then that will be a second point, and then I'll show you how we can get the third point from that. So to find the y-intercept is when x equals 0. So when x equals 0, what is my y? And so I'm just going to plug in standard form, you can just look at the last number and that's your y-intercept, because when you plug in 0 for x, you end up getting 0 minus 0 plus 5. So if you're plugging in 0 for all of your x's, those end up becoming, the first 2 terms end up becoming 0, and your last number will be your y-intercept. So I have an ordered pair at 0, comma 5. So I'm going to put a dot here.
Why are you going down?
I don't know why I'm going down. I think I graphed that all wrong. It should be negative 1, 7 up here. Yes, Riley, way to go. Get my positives and negatives mixed up. So something about a parabola is that when you have your axis of symmetry, that means that on either side it's a mirror image of each other. And so if I have a point at 0, 5, that means that I'm 1 x value away from my vertex. That means that I can draw an identical dot. Like if I reflect it, you know, a little geometry, if I reflect it over the axis of symmetry, that means I also have an ordered pair at negative 2, 5. So that just means that they're both, like both of these values are 1 x value away. And so just think about if your axis of symmetry is in the middle, you can literally flip it over and it's going to be a mirror image. So they're going to look identical on either side. And then you can just draw down and that would work. Yes?
Is it always going to be the y-intercept? Is the x always going to equal 0?
Uh-huh. So the y-intercept is always when x equals 0. Another thing that is helpful when you're plotting points, and this only works sometimes, so I'm going to say it, but I want you to make sure that you don't take it all of the time. So anytime that you have an a value, that is essentially like a vertical stretch. So that means that your a is greater than or equal to 1. So if you have an a value that is 1 or more, or negative 1 or less, like if the a value itself, so I guess I should say absolute value of a, is greater than or equal to 1, you can go from your vertex and use that as a slope 1 x value away. So if you notice, my vertex was at negative 1, 7 right here. My a value is negative 2. So if I go down 2 over 1 on either side, I can then connect the dots, and I can draw 3 points. That only works if you have an a value that is 1 or greater, the absolute value. If you have a fraction, so if you had like 1/4 or you had a vertical compression, it would not work. You couldn't go down 1 over 4 on each side. So the quote-unquote slope, I guess, the vertical stretch, you can do that 1x, it works 1x value away from the vertex. And that's just a little shortcut. Sometimes I hesitate saying it because I think people take it too literally and they do it all the time, but it doesn't work with a fraction. So if you have an a value that is greater than or equal to 1, you can take your vertex and use that as a slope 1x value away. So then lastly, the domain and range. Domain for parabolas is always the same. So that's going to be an easy freebie point on your test. Domain is always negative infinity to positive infinity. Always, always, always. It's always going all the way left and all the way right. Your range will be different depending on whether it opens up or opens down. So if it opens down, then you're going to have an upper bound. And then if it opens up, then you're going to have a lower bound. So what would my range be in this example? Negative infinity to 7, perfect, and then I'm going to have a bracket. Okay, so looking at this, it opens up because my a value is positive, which means in turn that I have a minimum. So these two go hand in hand. If it's opening up, that means I have a minimum value. My minimum is going to be at 3, negative 6. And I got that because my axis of symmetry, remember, is negative b over 2a. So when I plug that in, I have a negative 6 over 2 times 1, which reduces to a positive 3. So my axis of symmetry is at x equals 3. To find my vertex, I must plug in 3 into my x. Remember to put your x in parentheses. So 3 squared is 9, minus 18 plus 3, which becomes negative 6. So I have an ordered pair at 3, negative 6. That would be my vertex. So I plot that point. The next point that I can plot, if you notice I have 2 red dots, and I'm going up 1 over 1, up 1 over 1 on each side. That is because my a value, so the absolute value of my a, is greater than or equal to 1. So like I said, you can always go one x value to the right and to the left using the a value if it is not a fraction. So if it is 1 or more, you can do that. And then I can plot another point at my y-intercept. My y-intercept is when x equals 0. So when x equals 0, y equals 3. So I have a y-intercept at 0, 3. And I got this point at 6, 3 by doing what? Does anyone know how I got that point? So if I have a point at 0, 3, how did I get? I reflected it, right? So if I'm 3 points away from the axis of symmetry, that means I can go out 3 more points. So I can reflect it because parabolas are mirror images of each other. So then I can connect the dots. If this were on a test or something, I would only be checking 3 points. So you could technically just have your vertex and then the y-intercept and then the point that's reflected across the axis of symmetry. So 1, 2, 3. You wouldn't necessarily need to have the up 1 over 1 on each side. However, it's easier for me to have an accurate picture if I go up 1 over 1. Okay, with number 3, it opens down because it's a negative a value. There is no b value. When there is no b, that you'll find that means that it is centered at the y-axis, and that means it doesn't shift left or right. So that b value kind of determines whether it's shifting left or right. So then it's centered at 0, 8. The vertex is at 0, 8. And then the y-intercept also consequently is 0, 8. So that is why I show you the little slope trick going 1 to the left and 1 to the right. Because in that case, I only have one ordered pair. So my y-intercept and my vertex are the same. So what other 2 points am I going to use? Well, since my a value is 2, that means that the absolute value of that is greater than 1. So that means that I can go down 2 over 1, down 2 over 1 on each side, just looking at my a value. But remember, if it were a fraction, like if it were 1/2, I could not go down 1 over 2, down 1 over 2. So it does not work with a fraction. If it is a fraction, then you would just need to test points. Like you could test x equals 1, x equals 2, x equals 3, something like that, and plug that in and get a y value without a calculator. Okay, let's try one more, number 4, and then we will be done. Okay, with this one, so now you don't have a c value, so that would be 0 because there's nothing out here. It opens up because of the positive a value, so that means that it has a minimum. My axis of symmetry would be negative 6 over 2 times 3, negative b over 2a, which becomes x equals 1. To find your vertex, you're plugging in your axis, like when x equals your axis of symmetry, to find your vertex, you're getting x comma y. So my x value is the axis of symmetry. My y value is what my y is when I plug in my axis of symmetry. And then my y-intercept is when x equals 0. So you're getting 2 different ordered pairs here. One is your vertex, which is your max or min. The second ordered pair that you're getting is the y-intercept, which is when x equals 0. So you'll end up having 2 ordered pairs, and then you can create a third one, because when I get my y-intercept at 0, 0, that means that I can plot a third point at 2, 0 because of the reflection upon the axis of symmetry. So they are mirror images of each other. So if 0, 0 is 1 point away from your axis of symmetry, then you're going to go out 1 to the right as well. My domain is always negative infinity to positive infinity, and my range is going to be, it's going to start at negative 3 and go to positive infinity. So this is number 2 on the test review. I just want to talk about what you would do if you had a fraction as an a value, because you can't do the up 1 over 2 for your a value. So my axis of symmetry is x equals negative b over 2a, so negative 2 over 2 times 1/2, which becomes negative 2 over 1, so just negative 2. Then my vertex, I'm going to plug in x equals negative 2, so 1/2 negative 2 squared plus 2 times negative 2 minus 3. You end up getting negative 7 plus 2, negative 5. So negative 2, negative 5. So I have my axis of symmetry and my vertex, negative 2, negative 5. So one thing that you could do, if I'm only requiring 3 points, then a good third point would just be to find the y-intercept. And so if I'm solving for the y-intercept, then you're just plugging in when x equals 0. So what would my y-intercept be when x equals 0 if I plug that in? Negative 3. So 0, negative 3. And then I can plot a third point at what could my third point be?
2, 5.
I already did negative 2, negative 5. Negative 4, negative 3. I'm just reflecting it across the axis of symmetry. So my suggestion, if you have a fraction in front, just trying to find your y-intercept, and then that'll be 3 points, and then you can just connect it up.
Oh, you just reflect it. Okay.
So you just reflect it across the axis of symmetry. But you will notice, here's what you'll notice. Look at this parabola. If I were to do the little slope thing, then I would go up 1 over 2, and that would put a point here, which is actually 1 x value below, so that's why it doesn't work, okay, because it is a compression. It only works when you have an a value that is greater than or equal to 1, the absolute value of it. So if you have a fraction in front, you're just plugging in x values, but my suggestion would be to find the y-intercept and then reflect it across the axis of symmetry, and then you'll have 3 points, and that's all I'm grading, so that's all you would check.